This video is sponsored by PCBWay. Welcome everyone. In this video I'm going to show you my new little project. It will be based on these small PCBs. You can see that these are double-sided PCBs, so both sides will be populated by components. And this project is about a rotary encoder PCB. So if you have been following me for a while, you could see that I typically use this module for my rotary encoder demanding projects. This is a relatively cheap module and it works quite okay in most of the cases, but I wanted to have my own module so I can use that in my future projects. And of course it will not be able to compete with the price of this module, but maybe the long-term reliability and the quality will be somewhat better. So the concept of this PCB is really the similar concept. So we will have a rotary encoder which will be placed here, and then we have a few capacitors and a few resistors used as pull-up resistors and RC filters, the capacitor and the resistor together. And then on the back of this panel there's another component which will be a Schmitt trigger IC. And I will show you the whole process, how everything is done and how it is assembled. And then we will make a little evaluation by measuring the output signals of this module. And as you can see, I have a bunch of PCBs, some in the background as well, and also I have a stencil, and both of them are provided by the sponsor of this video, PCBWay. So if you have a similar electronics project where you need to produce a PCB and you need a stencil, don't forget to visit PCBWay's website, because they are expert in this kind of services to manufacture very nice PCBs and provide stencils for them. And also now they have a design competition where you can submit your design and compete for very nice prizes. So don't forget to visit their competition related website as well to contribute and then participate in that project. So coming back to these modules, as I said, they will accommodate a rotary encoder, and for that I will run different types of tests. And the first test will be that I have two different types of rotary encoders. This I just bought from Amazon, and this is an unbranded rotary encoder, and it just looks like as a typical rotary encoder in other modules. Probably they come from the same supplier or manufacturer, I don't know, but both of them are unbranded. And then the funny part is probably this one. These are fancy rotary encoders, or at least they were pricey, so hopefully this will be a much better quality. And then I will build a few modules with these rotary encoders and another set of modules with these encoders, and we will discuss their signal quality, and then I will check it with some oscilloscope and microcontroller just to see how this module can compete, for example, with this let's call it Aliexpress module. So to prepare these modules I will need a larger magnification because they are relatively small. So I will move to another camera and I will show you how I assemble this under a microscope, and then we will see how it works. So as you could see, I finished the soldering process. Here is one of the boards. So once the camera manages to focus, you can see the components. So on the top we have the rotary encoder. It has a switch. And then it has the passives on the top. And of course some connections. And then at the bottom, as you could see, we have also a chip. So once we get the focus, I can explain what this is. So this chip is nothing else than a Schmitt trigger inverter. It has 3 channels. So that means that I can apply the Schmitt trigger both on the 2 switches of the rotary encoder itself and then the switch of the push button as well. And what the purpose of this is that it works together with the passive components. So the passive components act as some kind of filter. So when the rotary encoder is being rotated or when its button is pushed, then the signal of it is typically bouncing. So it does not go to low immediately, but it can bounce back because of the quality of the contacts. And then that is being smoothed by the filter. But then to be sure that we get the proper signal, the output of that filter is then directed into this Schmitt trigger chip. And then the output will be inverted, but then in software it's very easy to handle it. And yeah, I know the bouncing can be handled in software as well, but maybe you don't want to do that because you cannot do it due to limitations. You don't want to deal with it, or you want to put this into a hardware which doesn't have a microcontroller logic and you need clean signals, then this could work as well. And just to show how the signal looks like, I will connect this to a oscilloscope, and then we will see how the signal looks like, and we will study the signals a bit. So the oscilloscope is running, and we have the circuit connected here. So I show you what is what. So I have this little circuit. And what I did is that I connected the ground of the power supply for the wall circuit to this pin. And of course the ground connections, these guys, together. And then this pin, the first pin next to the ground, that belongs to one of the switches inside the rotary encoder or connections. And then the second pin or the third pin in the wall row here is the other switch. And then this is the physical switch, the push button part that is not connected. And then here I have 3.3 volts power supply. So then what we should see here is just some very nice square waves. So let's see if we have that. And first I will turn this clockwise. So that means that I will rotate it like this. And then I will rotate it in the opposite direction just to see how the signals look like. So now the trigger is continuous, so I just rotate this and see how the signals look like. And we just have some waves. So I set up a single trigger and then I just vigorously rotate this thing to have a lot of waves or a lot of pulses. There we go. So let's say, magnify this one here. And I just want to show you something cool. Or, yeah, probably if you watch this video, you find this cool. Then you can see that here, hopefully you can see, the first pulse is from the yellow, and that is here, the second pin. And then the purple is the third pin, and then the purple is shifted. So that can be used to guess the direction. And you can see that all these signals have a very nice square wave, and that is just the result of the Schmitt trigger circuit. So that creates a very nice square wave output. So I saved this picture. That was easy. Then I go back to single trigger again, and now I rotate it in the other direction just to see what happens. And now you can see that each time the purple is the first square wave. So that always comes, let's say, half a phase or half of peak time earlier than the yellow, because I was rotating it in the opposite direction. So this is actually how you should program, or how we program the rotary encoders in general, that we know that if we rotate in one direction, then one pulse comes the first, and if we rotate in the other direction, then the order of the pulses flip. And well, that is actually what we see here. I just try to produce some more pulses again. This will be good enough. So I save these, and I can upload them on my website and write a nice article about this thing. So yeah, this is now saved. And one more interesting thing could be, which requires some soldering, so I will do that, is to see the signal before the Schmitt trigger. So I will just solder some wires on this circuit. I try to solder at least, and then I can hijack the signal just from the output of the rotary encoder, and then we can compare the signals before and after the output. So the next setup is done. So as I said, I hijacked the output of the rotary encoder. So here what we can see is the following. This is the bottom of the circuit, and then this guy here, this pin, is one of the outputs. This is a common pin, the center, and then here we have another output from the rotary encoder. So I just simply solder the wire to the two pins here on the sides, and that is the direct output of the rotary encoder, so this pin and this pin. And then of course I'm observing one of these pins on the outputs, which is the output of the Schmitt trigger circuit. So now that is already set up here. I turn on the power supply. So let's rotate the rotary encoder and see how the two signals look like. So first, let's look at the output of the rotary encoder, and that is the second channel, the purple one. So I remove the yellow one, and this is what we have from the filter. So you can see that this is actually already a nice signal, and we are basically just always focusing on the falling edge. So actually this is totally fine for a microcontroller. So this actually we can work with without any issues. But then just to show you the other channel, which is the output of the Schmitt trigger, I remove the purple channel. You can see that these are like perfect, very nice square waves. So this is even better. And if you have some other circuit where you cannot apply a logic in software because you rely on, let's call it, hardware signals, so like in this case kind of an analog signal, then it's better to use the Schmitt trigger. And as I said, the Schmitt trigger actually also has an inverter on its output, and that we can see very nicely. So here we have a high signal, and then the signal falls, and then it stays 0 for a while, and when there is contact again in the rotary encoder, then it goes up. So basically, if I'm not wrong, we just simply recharge the capacitor, and then that's that. So this is like a falling signal here and here, but then I remove this, put this back, and this is a rising signal. So that just the inversion looks very nicely here. So that's that. So let's rotate one more time. And again, we see the nice signals. So if I magnify, then we can see how the two signals look like. So I think that they are quite okay. I will try some more signals, something like this. So I think this looks quite nice. So I will save this. So this picture is from the filter. And then I also want to look at this. And sure, I want to just focus on this. So these are nice. And FYI, this encoder is the worst one. So this is the worst quality encoder which I just bought from Amazon. It doesn't have any particular brand or anything. And we can see that the quality of the output signal, even after just filtering, is probably more than sufficient for handling it with a microcontroller. But then, of course, if we add the Schmitt trigger, then we have absolutely good signals. So I think then this circuit is good. So it passed the test in my head, at least. So for me, this will be sufficient. And I think I will stick to this design in the future because it looks quite reliable. But what is very important for me is that I think that it's worth it to struggle with this chip in the back and solder it, because it gives very nice square waves. So I think that could be something to kind of take away from this encoder. And from the conclusions of this video is that yeah, the RC filter already has a good result. If I just put it back, this is already a nice signal. But then if we just support it with a Schmitt trigger, we get the perfect square waves that we need for our rest of the circuit, wherever we need rotary encoders. So if you are interested in this project, visit my website, because I shared the resources about this project and everything. And also don't forget to visit my PCBWay project page, because there I share this design. So you can buy the PCB from PCBWay. I also shared all the other files which are necessary to produce the whole PCB. So either PCBWay can do it for you, or you can just buy the parts. I shared all the materials and the part numbers and everything. So either PCBWay can do it for you, or you can do it for yourself. Then you can have a very nice encoder board. And probably this is a bit more expensive than the other board, this guy here. But I would say it's maybe a bit better. But it's kind of similar shape factor, so it's not too much difference. Mine is more squarish and this is more round. But yeah, the pins are actually the same. So of course, when I designed this board, I took the same sequence of the pins here. So if you want to ditch this, you can replace it with that. And that's my idea actually for my upcoming projects. So I can have my own encoder in my future circuit boards. And basically that's that. So I hope that this video was useful to you. I hope you learned something, and see you in the next video.